Hello everyone, in this video I'm going to explain pointers in C or C++. So I'm going to explain what they are, how they're used, where they're used and how we can use it while writing code. And if you're watching my video for the first time, then my name is Ashish Kumar. I make videos on competitive programming, data structures and algorithm, placement preparation, interview preparation, etc. So if that's your content, then do subscribe to the channel and let's get started. Okay, so what is a pointer? A pointer is pointing towards something, right? Like the name suggests, pointer points towards something. But a more technical definition would be something like this. That pointer is a representation of an address. Okay, but what does this mean? So suppose I have a few variables. So suppose I have these variables, I have int x, I have char y, I have float z. So we use variables in C, C++ and basically every language, right? So quite basic. But one thing is that every variable that we use in our program is stored at an address, right? So int x will have an address, char y will have an address and float z will have an address. So that pointer contains the address of a variable. So like I said first, pointer points towards something, right? So pointers points towards something. Now what is that something? That something is a variable. So a pointer basically points to a variable, okay? So a pointer points to a variable and it contains the address of that variable. So it's a representation of an address, or more specifically address of the variable it points to. So a pointer contains the address of variable it points to. Okay, so that's it about a pointer theory wise, that pointer points to a variable and it's a representation of an address, more specifically address of the variable it points to. Okay, now let's see how we declare pointer and how it actually looks like. So let's use integer for now. It's pretty much the same for everything else. So suppose I have an integer x is equal to 2, right? Now I want to declare a pointer which is going to point towards x. So first things first, the pointer should have the same data type as the variable it's pointing towards. So what's the data type of this variable? Int, right? So my pointer should also be of type int. So it will be something like int star p. Now star declares, so star in the declaration, asterisk in the declaration shows that it's a pointer, okay? And like I said, pointer points towards something, so we want to make it pointing towards x. So how are we going to do that? So we have a pointer called p and I'm going to say p is equal to and x. Now this right here, the symbol and is called the address of operator. So if you read this, it's going to be something like p is equal to address of x, and that's what we wanted to do. So p is a pointer and p now contains the address of x, and so it points towards x. Now if I print p quickly, then you can see that it will have the address of x. Okay, so you can see that it has this something, and this is how an address looks like in our program. So this is the address where we have stored x. Now if I want to print star p, so this will give me the value which is at that address. So p is the address and star p is the value at that address. And what's the value at that address? It's 2. So x is address is this and x's value is 2. Now I can make changes into x by making changes into star p. So suppose I say star p is equal to star p plus 2. Now again when I print star p, then it should be 4, and now when I print x, it should also be 4. So that means that when I make a change to star p, then a change is made to x as well. Why? Because it's the same thing. P is pointing towards x, p is a pointer, p has the address of x and star p has the value of x. So both of them are the same thing. So if I try this, what will happen? So initially I had the address of x, then I had the value of x, and then I said star p is equal to star p plus 2, which means that x is now 4. So when I print star p, which is the value at p address, that is 4, and the value at x, that is 4. So this is important. So meaning that whenever I make a pointer towards a variable and I make changes through that pointer, the variable itself will change. Now this brings me to where pointers are used. So I'll just write that down. So where pointers are used. Okay, so pointers are used for two reasons. One, to make call by reference call by reference. So in C and C++ we make function calls, right? So there are two types of function call. They're either a call by reference or there's a call by value. So we use these to call by reference, and the second use is for data structures. Okay, so if I make a linked list, so recently I made a video about linked list in C++ and I did this using pointers. Okay, so pointers are used to call by reference and then they're used for data structure, and I'll show both of these uses with examples. Okay, so let's see both of these uses one by one. So like I said, one is to call by reference, to make a function call by reference, and second is for data structures. So let's see how we make a function call using reference. So I have two functions here. One is int twice of 1, which is taking x and returning twice of x, and second one is void. It's not returning anything, it's taking x, but both of the functions are doing the same thing. Both of the functions are doubling the value that they're taking. Now the first one is called by value. Quite simply, it's taking an argument and it's returning an argument. But the second one is called by reference. You can see that it's not taking an integer argument, it's taking a pointer argument. Okay, so this is a call by reference, it's not a call by value. So let's see how both of them are working. Like I said, using a pointer I can make changes into the variable it's pointing towards. Okay, so that's something that call by reference uses. So anyways, let's see. So suppose I have two variables, I have p and q, and both of them are 3. So p is 3 and q is 3. Now first let's see how twice of 1 is working. So I'll print something like p is and then p. So it will be something like this, p. So this will print what p is, okay? And then I'll say cout twice 1 of p. So I'll say how the function is working. And then I'll print p again to see that whether any changes in p were made or not. Okay, so let's see this. Let's run and see this. Okay, so you can see that p is 3, twice 1 of p is 6, but again p is 3, meaning that no changes was made to p itself. So when I use twice 1 in p, p didn't change itself. Twice 1 of p simply returned twice of p, right? Now let's try twice of 2 of p and see how that is working, right? So I'll just say cout q is, and yeah, so I'll just write cout q is and then print q. Okay, and then I'll simply call, so I'm not printing anything, I'm just calling because it doesn't return anything, right? So I'm saying cout twice of 2 of q. So I'm just calling twice of 2 of q, and then again I'm printing cout q. So now again I'm printing what q is. Okay, now let's try this. Okay, we have to return the address. Okay, so glad I got this error. So here we're sending in the integer p, but here we cannot send q. Why is that? Because this is taking argument a pointer, meaning that it's expecting an address. So we have to send the address. So that will be address of q. Quite simple. Okay. Okay, so p is 3 and 6, then again p is 3, and then q is 3, and then I'm calling the function, and now q becomes 6. So when I call by value, the variable itself doesn't change, right? The function I'm calling and it's returning twice the value, but the variable doesn't change. However, when I call twice of 2 of q, then the variable itself changes, which means that without returning anything, we can make changes to the variable. Now I can have as many variables as I want. I can have int star y, I can have int star z, so I can have as many variables as I want, and I can make changes to all of them without having to return anything. So this is the benefit of using call by reference. Now let's see where we use it in data structures. Okay, so I'll explain how pointers are used in data structure very briefly. So this is the code I took from my previous video, linked list in C++. Okay, so in every data structure almost there is a pointer, right? So for example, in linked list we have a node which has a data and a pointer to the next node. So that is nothing but a simple pointer of the data type of the node itself. Like we had int star p, this is node star next. Next is the name, and this is of the data type node, because like I said, the pointer should be of the same data type as the variable it's pointing towards. Okay, now I have two functions here, insert, and I also had delete, but right now I have insert. So when I want to insert something, you can see that I'm not returning anything. Instead, I have it as void and I'm sending the head of the linked list. So by just sending the head of the linked list, I can make changes into the whole linked list, okay, without returning anything. So that is the power of pointers by using call by reference. So I'm just sending the head of the linked list. That's it, the address of the head of the linked list, which is a pointer, and then inside that, whatever changes I made, it will be made to the whole linked list. So like that, we can use call by reference, we can use call by value, and the same things are used for making complex data structures and manipulating them. So that's it guys for the video. I hope you liked it. If there's any doubts, put them in the comments. I'll be sure to answer. Thank you.